Okay, so in the last video we took a look at the SAS congruence criterion, which was the one that told us that if we have two sides on one triangle congruent to two sides on the other, and then the angles between the sides are congruent, then that would be enough for us to say that the triangles are congruent. In this video we're going to take a look at another congruence criterion called SSS, or side, side, side. And this one's a little more straightforward. Basically it says that, hey, if you got two triangles and each side of one triangle can match up to a side of the other triangle as congruent, then that means that your triangles are going to be congruent. So in this picture here we got segment AB that's congruent to segment ED, we got segment BC congruent to segment EF, and we got segment AC congruent to segment DF. And so each side of this triangle has like a match or a partner that it's congruent to in the other triangle, and that makes these two triangles congruent. So we now have SAS congruence and SSS congruence, and let's take a look at four quick examples and see if either one of those congruences fit for these four different pairs of triangles. So I see this first one, and it looks to me like SSS might work for this one, because I have this side congruent to this one, this side congruent to this one, and this side congruent to this one. So each side of this triangle has a match, or a congruent side, on this triangle. So we're going to say for this one that it's yes by SAS, that the two triangles are congruent. In part B here we have, it looks like a couple sides and an angle on this one, and we have a couple sides marked and an angle on this one. So maybe we have SAS. We have two sides and an angle. We have two sides and an angle. So it looks like we could be looking at SAS in this one. What we need to check is to make sure that that angle in each triangle is the included angle. It's the angle that's formed by these two sides. So I just like to sometimes highlight what we're dealing with here to kind of check that out. So I'm going to use my yellow pen here to mark that this side and this side are congruent. And then let's use purple to mark that this side and this side are congruent. And then let's use another color, we'll say blue, and show that, hey, look, there's the angle that's made by the yellow segment and the purple segment. It's congruent to the angle in the other one that's also made by the yellow segment and the purple segment. So this one looks like it's going to be yes by SAS. Now if we move to part C here, we're going to see something that looks kind of similar to part B, because I have two sides and an angle in the triangle on the left. I have two sides and an angle in the triangle on the right. So maybe we're dealing with SAS again. But let's do the color coding thing that I just did in that last one. Let's mark that this side is congruent to this side. We'll color code them yellow here. We'll grab our purple. We'll say that this side and this side are congruent. They have the matching marks. But then if I notice that the angle that's marked in each, it's not the angle that's formed by the two sides that I colored in yellow and purple, right? That would be this angle. This angle right here would be the included angle for these two sides. And then the same thing happens over here. This angle right here would be the included angle for these two sides. So even though we do have two pairs of sides and a pair of angles congruent between these two, SAS does not work in this example. So we have to say no. Lastly, we have example D. And again, it looks like I have two sides and an angle here on the top triangle. I have two sides and an angle here on the bottom. Let's color code, see if it works out to be SAS. So this congruent to this. And then I have this segment here that I'll color purple, congruent to this segment here that I'll color purple. And then let's color the angles in blue here. And I notice, hey, it looks like my angle is formed by my purple segment and my yellow segment here. The angle is formed by the purple segment and the yellow segment on the lower triangle. So I think this one is going to be a yes by side angle side. Okay, so moving on to the next example. It says, what additional information is needed to show that these two triangles are congruent by SAS? And then we're going to say, well, what if we wanted to do SSS? So let's kind of list out here what we know, right? What we know. What we already know is congruent. First of all, I already know that angle A is congruent to angle D. So I like to just mark off to the side, hey, that's one pair of angles. Then I also know that segment AB is congruent to segment DE, and that's a pair of sides. So if I'm wanting to say, hey, these are going to be congruent by SAS, right now I don't have enough information to say that that's true, which is kind of the point of this problem, right? It's asking what additional information would be needed to use SAS. But if I look here, I have an angle, a pair of angles. I have a pair of sides. So I'm clearly missing a pair of sides, right? I have the S and I have the A. I'm missing one other S for using SAS. So the question is, which other pair of sides would give me SAS so that the angle is the included angle, all right? So let's kind of color code it like we did on the last example. We have this segment congruent to this segment. Our angle that's congruent is here and here. So now we want that blue angle that I just colored to be the one that's included between the yellow one and then the next one we're going to name. So I can pretty clearly see that I'm going to need segment AC. Let's color it purple here real quick. Segment AC is going to have to be congruent to segment FD. So my answer will be that I need, or say we need, and then we'll say we need segment AC congruent to segment DF. That would give us SSS, all right? So that would be the SSS answer. Well, what about side, side, side? Well, we clearly see that for side, 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 we just need every side of one triangle to be congruent to a side on the other triangle. We already have AB congruent to DE. So what we would need for SSS is we would need the other two pairs of sides. So we would include segment AC congruent to DF as part of our answer here. But then we would need the third side. Let's just grab a color here. I haven't used green, so let's make it green. I would need segment EF to be congruent to segment BC, right? So the second thing I would need for SSS would be for segment BC to be congruent to segment EF. Okay, now our next example says, is triangle STU congruent to triangle XYZ? And then explain. So we have to look at the markings that we have, and we have to decide if these two triangles have to be congruent by either SAS or SSS. Well, let's list out the things that we know are congruent between these two triangles. We know that segment SU is congruent to segment XZ. Let's color code those, right? We know that that's congruent to that. They have the same markings. We know that, let's use another color here. Let's use this turquoise color. I like that one. We know that segment TU is congruent to segment YZ. Segment TU is congruent to segment YZ. And then we have an angle that's congruent. We have angle U here that's congruent to angle Z right here. Okay, so that is, we have a pair of angles here. We have a pair of sides here, and then we have a pair of sides with this one. So I have two pairs of sides and a pair of angles, so maybe SAS is what we have. We just need to verify that this angle right here is the included angle between these two sides, that it's the angle that's made by these two sides. And if I look at my picture, yes, it is, right? This angle that I've marked in blue is created by the purple and the turquoise segment, just like this angle over here is made by the purple and the turquoise segment. So my answer is going to be that yes, triangle STU is congruent to triangle, and then I got to be careful here in how I name the second triangle, because remember, when I'm making a congruent statement like this, I am saying which parts of this triangle correspond to the parts of the other triangle. So whatever corresponds to S has to be the first letter I name here. So if I look at S right here, it's at one end of the purple segment. It's at the end that's not including this angle, or doesn't have this angle on it. So that would match up with X. So my first letter on the other triangle's name is going to be X. And then the next letter I listed here was T. So I got to think what corresponds to this point over here on this triangle, and that would be Y, because it's at the end of this turquoise segment, but it's the end that doesn't have the blue angle at it. So that looks like Y right there. So that's going to be my next triangle, or my next letter in this triangle's name, and then that would leave Z to be the third letter. So yes, these two triangles are congruent by SAS. All right, let's take a look at one more example. It says, is any additional information needed to show that these two triangles are congruent by SAS? So let's look. Maybe the answer is no, we don't need any more information, because I noticed that I have two segments and an angle marked here, and I have two segments and an angle marked here. So maybe my answer is going to be no, but let's take a look. What I already know is that segment EF is congruent to segment JH, right? I know that segment EF is congruent to segment JH. That's one of my pairs of sides. I know that segment DF is congruent to segment GJ. Segment DF is congruent to segment GJ. That's another pair of sides. And then it's got that angle E is congruent to angle H. Angle E is congruent to angle H, which is a pair of angles. So like I mentioned, I see I have two pairs of sides and one pair of angles. But the problem is this pair of angles here is not the included angles for these two sides. It's not the angle that's made by the yellow segment and the purple segment, right? That would be angle F and angle J. So if I wanted to say that these were congruent by SAS, yes, I would need additional information. So I'm going to say yes, angle F would need to be congruent to angle J to use SAS. Or the other thing I could say is that, hey, maybe I'm going to use this as an included angle, but in that case I would need GH to be congruent to DE. You know, let's color code that real quick. Let's throw that turquoise color back on there. I would need this segment to be congruent to this one, and then that yellow angle in both triangles, that yellow angle would be the one made by the turquoise and the yellow segments, turquoise and yellow. So I could add to my answer here. I could say, or segment ED needs to be congruent to segment GH. If I wanted to use SAS, one of these two things would have to be true. What they give me to start this problem with these things being congruent, that's not enough to use SAS because the angle is in the wrong place. It's not the included angle. So just to wrap this up, what are we looking at in this video? Well, or in this section, section 3, we learned two things, two big ideas. First, we learned that two triangles can be congruent by the side angle side theorem, which is where we're going to have a pair of sides here and here. Let's do our color coding thing again. I think it helps. So I could have these two sides congruent. I could have these two sides congruent. And then I could have the angle that's between them congruent. And in that case, that would be enough to say that the triangles have to be congruent. We also learned a little more straightforward one, which says that, hey, if all the sides of this triangle, so if all the sides here, let's color code these three sides, have a match on the other triangle, so the yellow and the yellow would match, the turquoise and the turquoise would match, and the purple would match. If that happens, we can say that the triangles are congruent by what we call side, side, side.